Hi guys, let's have a look at auxiliary programs and data under the topic simulation tools. So the first tool that we're going to look at or program is called HoriCatcher, also called Solar Pathfinder. It's a product from Meteonorm. Basically with horticulture you can digitize the local horizon and shadowing situation effectively and precisely, and import the horizon into Meteonorm for even more precise results. And also the output of HoriCatcher can be used for simulation tools such as PVSol and PVSYST. So that's what it looks like. It's basically just a metal ball with a camera on top that's 100% horizontal, and the horizon is reflected in the metal dome. So there's another picture of what it looks like, where some buildings is reflected on the horizon that will cause a lot of shadows, and these images can then be imported into Meteonorm to show you the shadows that will be on a specific location. So the second program we're going to look at is Meteonorm. That's basically a global meteorological database or weather database. So it's for any location worldwide. And it's not just irradiation, but it can also give you other weather data such as wind speed and humidity and so forth. And you can even get accurate values for monthly, hourly and minute values. It's a desktop-based application that you can download and install. And you can export the weather data to many other formats. And as I said, it's used by all the major simulation tools such as PVSYST and PVSol. So that's what the demo version looks like of the application. So you can select a location, and then there's different output formats, and you can compare different cities with each other. And here you can see radiation graphs, temperature graphs, precipitation, sunshine duration, and so forth. Great. So the third program we're going to look at is PVGIS, or Photovoltaic Geographic Information System. So it gives you aeration and specific yield values. You can adjust the orientation and slope of your panels, and based on that it will change the yield. It's a tool you can quickly use for simple sizing, and it's free and it's web-based. Great, so that's what it looks like. If you go to the address, you select your location either by address or by longitude and latitude. And then you can select different types of systems like grid connected, tracking PV, off-grid and so on, or just with sunshine data. So you type in here the size of your solar system, your expected losses, the slope or the incline of the panels, and the azimuth or orientation of the panels. 180 means north and 0 means south. And you can even put in some electricity prices if you want to. And then you click on visualize results. Once you click that, you'll get this result. And the most important figure here is the yearly energy production, which is 1,700. Most people in countries like Germany, in Europe and so on, will be jealous of this figure. In Germany, it's mostly about 900 kilowatt hours for each kilowatt installed. In South Africa, Pretoria, there's a lot of sun, and it's almost double at 1,700. And you see also the production per month is about 150 kilowatt hours, 140, and it's a reasonably flat production curve. Also in Europe, the winter months, November, December, January, February, there's very little production in solar, but South Africa is quite blessed with a lot of sunshine. Great, so the next tool we look at is called SunCalc. You can access it also online at www.suncalc.org. So it's used to calculate sun paths and angles, any date and location on Earth, and you can also use it to calculate shadow lengths. So it's a very handy, quick tool to use, and its interface looks like this. So you also give it a specific location, and then you come to this screen. On top here is a slider that you can slide from 7 o'clock in the morning to 4 o'clock in the evening. And as you slide it, you'll see this sun path changes in the sky. And it's also based on the specific date that you select here. So it's quite nice to see how the sun moves through the sky during different times of the year. It also indicates here the shadow length. As it's quite early in the morning on this specific screenshot, the shadow length is quite long at 27.9 meters. So definitely a nice tool to work with, and the shadow length is also quite handy if you want to calculate, for example, how far to put rows of solar panels away from each other if it's installed at an incline. Then lastly, there's a long list of databases with meteorological data that one can download. All of these slides and information will be made available to you.